Imagine a place where gravity is king, a realm where the very fabric of space and time is warped beyond recognition. When you look up at the night sky, you see countless stars twinkling, galaxies swirling, and the vastness of the universe stretching out before you. But hidden among these cosmic wonders are objects so mysterious and powerful that they defy our understanding. These are black holes, the ultimate rulers of gravity, lurking silently in the darkness. Imagine a place so dense, so compact that nothing, not even the fastest thing in the universe, light itself, can escape its grasp. Black holes are regions in space where gravity has become so overwhelming that it pulls everything inward, trapping even the tiniest particles of light. They are invisible to the naked eye, yet their presence is felt by the way they bend light and distort the space around them. This is a black hole, a cosmic abyss, a bottomless pit in the universe, born from the violent death throes of massive stars. When a star much larger than our sun reaches the end of its life, it can no longer support itself against the force of gravity. The star collapses inward, its core shrinking to an unimaginably small point, while its outer layers are blown away in a spectacular explosion called a supernova. What remains is a black hole, a region where the rules of physics as we know them no longer apply. Picture a star many times larger than our sun, burning brightly for millions of years. Over time, it exhausts its nuclear fuel and gravity takes over. The star collapses in on itself, shrinking smaller and smaller until it forms a singularity, a point of infinite density. This is the heart of a black hole, where all the mass of the star is concentrated into a single, infinitely small point. The result is a singularity, a place where the known laws of physics break down. Here, gravity is so intense that it warps space and time to their limits. Scientists believe that at the singularity, the concepts of space and time as we understand them cease to exist. It's a mystery that challenges even the most brilliant minds in physics, and one that remains unsolved to this day. Surrounding this singularity is the event horizon, the invisible boundary that marks the point of no return. Once anything crosses this threshold, it is lost forever to the black hole's gravitational pull. Not even light can escape, which is why black holes appear completely dark against the backdrop of space. The event horizon is like a cosmic trapdoor sealing off whatever falls inside. If you were to cross this boundary, you would be pulled inexorably toward the singularity, unable to escape. The gravitational forces near a black hole are so extreme that they would stretch and compress anything that comes too close. A process scientists call spaghettification. Matter spirals inward, heating up and emitting powerful X-rays before vanishing forever. It's a one-way ticket to oblivion, a place where time slows down and space is twisted beyond recognition. Near a black hole, the normal rules of reality break apart. Time itself can appear to freeze for an outside observer, while for someone falling in, the journey to the center is swift and inescapable. Black holes are the ultimate cosmic enigmas, challenging our understanding of the universe at every turn. But what if one of these celestial monsters came close to our own planet? What would happen if Earth were to encounter a black hole? Would we be able to see it coming, or would it silently pull us in, changing our world forever? The mysteries of black holes continue to captivate scientists and stargazers alike, reminding us of how much we have yet to learn about the universe we call home. Imagine standing outside on a quiet night, gazing up at the vast expanse of the night sky. The stars twinkle above, familiar and comforting, scattered like diamonds across a velvet canvas. But then, something changes. You notice a patch of darkness, a void that seems to swallow the stars around it, growing larger and more ominous with each passing day. The people around you begin to notice it too, murmurs of unease spreading as the blackness expands, blotting out constellations that have guided humanity for millennia. The sense of wonder is slowly replaced by a creeping dread, as the sky you once knew transforms before your eyes. As the void grows, the stars near its edge begin to behave strangely. Their light bends and twists, warping into strange arcs and halos. This is no ordinary darkness, it's the signature of a black hole, an object so dense and powerful that not even light can escape its grasp. The immense gravitational pull distorts the very fabric of space and time, creating a cosmic funhouse mirror that stretches and bends the starlight into surreal, beautiful patterns. Astronomers scramble to capture images and data, realizing that the universe is putting on a display of gravitational lensing on a scale never before witnessed from Earth. Soon, it becomes clear that this is not a distant phenomenon. Earth itself is on a collision course with this cosmic monster. The realization sends shockwaves through every corner of society. Scientists, governments, and ordinary people alike grapple with the implications. Our planet is being drawn inexorably toward a black hole, an event that marks the beginning of the end for life as we know it. The world watches in awe and terror as the black hole looms ever larger in the sky, its presence an inescapable reminder of the universe's raw, indifferent power. With each passing day the sky grows darker, the sun sets earlier, and the nights become longer and more oppressive. Shadows stretch across the land, and the familiar blue of the daytime sky fades to a perpetual twilight. The darkness is not just a lack of light, it is a tangible force creeping across the horizon, swallowing everything in its path. People gather outside watching as the last vestiges of daylight are consumed, feeling the weight of the unknown pressing down on them. The world feels smaller, colder, and more fragile than ever before. As Earth draws closer to the black hole, the effects become even more dramatic. The planet itself begins to stretch and contort, pulled by the immense tidal forces generated by the black hole's gravity. The difference in gravitational pull between the side of Earth closest to the black hole and the side farthest away becomes extreme, causing the very shape of our world to distort. Oceans surge and continents shift, as the forces at play threaten to tear the planet apart. Scientists try to model the chaos, but the reality is more terrifying than any simulation. A world literally being pulled to pieces by the invisible hand of gravity. The night sky, once a tapestry of familiar constellations, is now unrecognizable. One by one the stars are swallowed by the encroaching blackness, their light extinguished as if they never existed. The constellations that once told stories and guided travelers are erased, leaving only a void where memories used to be. For the first time in human history, the universe feels truly alien, an endless, empty expanse with no points of reference, no comfort, and no hope. The loss is not just scientific, but deeply personal, as humanity mourns the disappearance of the cosmos itself. As the black hole's grip tightens, the very fabric of our world begins to unravel. The atmosphere is stripped away, torn apart by forces beyond comprehension. The surface cracks and buckles, and the planet itself starts to break apart, fragments spiraling into the abyss. In these final moments, Earth is transformed from a vibrant living world into a collection of debris, lost to the darkness. It is a stark reminder of our place in the universe, fragile, fleeting, and at the mercy of forces far greater than ourselves. As Earth plunges deeper into the black hole's gravitational well, the tidal forces would grow stronger. Imagine being stretched like a piece of spaghetti, your head and feet pulled in opposite directions with unimaginable force. This is spaghettification, a rather unpleasant consequence of encountering a black hole up close and personal. Every atom in your body, every molecule of air, even the very fabric of space-time itself would be stretched and distorted beyond recognition. It's a bizarre and unsettling thought, but it's a consequence of the extreme gravitational gradients that exist near a black hole. It's safe to say that surviving this cosmic tug-of-war would be a tall order, even for the most resilient life forms. One of the most mind-bending aspects of black holes is, honestly, their effect on time. When we think about time, we usually imagine it as something steady and reliable, a constant tick-tock that marches forward no matter what. But black holes challenge this very notion, twisting our understanding of time into something almost unrecognizable. The closer you get to a black hole, the stranger time behaves. It's as if the universe itself is playing tricks on our most basic assumptions. Einstein's theory of general relativity tells us that gravity warps time, and well, nowhere is this effect more pronounced than near a black hole. Imagine space-time as a giant, flexible sheet. Place a bowling ball on it and the sheet dips. That's what a planet or a star does to space-time. But a black hole? It's like dropping an anvil onto that sheet, creating a pit so deep that not even light can escape. The gravity is so intense that it doesn't just bend space, it stretches and compresses time itself. This warping isn't just a theoretical idea, it's a real measurable effect that has been confirmed by experiments and observations. As Earth falls towards the event horizon, time itself would begin to slow down for us, relative to observers far away. To someone watching from a safe distance, it would look like we're moving in slow motion, our clocks ticking more and more slowly as we approach the edge. This isn't just science fiction, it's a consequence of the way gravity affects time. The stronger the gravity, the slower time moves. Near a black hole, This effect becomes so extreme that, from the outside, it would seem as if we're frozen in time, forever teetering on the brink of the event horizon. Imagine sending a message back to Earth from the edge of the abyss. At first, our signals would arrive at regular intervals, just as you'd expect. But as we get closer to the event horizon, something remarkable happens. Each message takes longer and longer to reach home. The intervals between them stretch out, as if the universe is hitting the slow-motion button on our transmission. To our friends and family back on Earth, it would seem like we're drifting away not just in space, but in time itself. To those left behind, our signals would take longer and longer to arrive, their frequency stretched and redshifted as if time itself were being stretched thin. The light from our spacecraft would shift to redder and redder wavelengths, a phenomenon known as gravitational redshift. It's as if our voices are being pulled apart, stretched into whispers that fade into the cosmic background. Eventually, our messages would become so faint and so slow that they'd be almost impossible to detect. From the outside, it would look like we're fading away, lost to the darkness of the black hole. From our perspective, though, the plunge into the black hole would seem to happen at a normal pace. We wouldn't notice anything unusual about the passage of time. Our clocks would tick as they always have, our hearts would beat at the same rhythm, and our thoughts would flow just as they do now. It's only when we look back, or try to communicate with the outside world, that we'd realize something strange is happening. The universe outside would appear to speed up, racing forward in time while we move ever closer to the event horizon. Time, it appears, is relative, a concept that takes on a whole new meaning at the edge of a black hole. Here, the familiar rules break down, and our everyday experience of time is turned upside down. What feels like a moment to us could be an eternity to someone watching from afar. Black holes remind us that the universe is far stranger and more wondrous than we can imagine, and that our perspective, where we are, how we move, and what we experience, shapes our very understanding of reality itself. In the shadow of a black hole, time becomes a matter of perspective, and the universe reveals just how flexible and mysterious its rules can be. Gravity, the force that holds our feet firmly on the ground, becomes a formidable foe in the presence of a black hole. As Earth draws closer to the event horizon, the gravitational pull would increase exponentially. This relentless force would have a profound effect on our planet, stretching and squeezing it like a cosmic stress ball. Oceans would bulge, mountains would crumble, and the very structure of our planet would be torn asunder. It's a sobering reminder of the immense power that black holes wield, a power that can warp the fabric of space-time itself. Even light, the fastest thing in the universe, cannot escape the gravitational clutches of a black hole once it crosses the event horizon.